Let's do some more examples involving differentiation of logs. Remember that when you're deriving log of an absolute value u, it's the same as log of regular u, because when you're deriving, the absolute value does not change the answer. It does not, however, go the other way for integration. So when we're going to find the derivative of this right here, it's really just the same as deriving natural log of this quantity without that absolute value. So we're deriving the natural log of some function of y, so the natural log of u. Our derivative involves u prime, so let's evaluate that. Pop down, power down, that's negative 6y squared. So our derivative is u prime, so negative 6y squared over u. And that's it. When possible, simplify logarithmic functions before differentiating them. And simplifying could involve expanding the log. So let's practice. Let's try rewriting this function with our natural log expanded. So I'm taking the natural log of this quotient, and in the numerator of the quotient, there is a product. So remembering our rules of expanding logarithms, we're going to take natural log of that product, natural log of x, plus natural log of the other piece in that product, and the denominator will be subtracted, natural log of the denominator. We're not quite finished expanding because there's another rule that if you are taking the log of something to a power, then that power becomes the coefficient of that log. Now, you may not see any powers here. You see there's a squared, but there's a plus 1 here. It's not the whole argument, and it has to be the entire quantity that is to a power. But this root could be rewritten as this quantity to the power of 1/2, which means that this 1/2 will now be the coefficient of this term. Now this looks like it's going to be a little bit easier to differentiate than this crazy fraction we started with. So let's differentiate it now. The derivative of natural log of x is 1 over x. The derivative of 1/2 times natural log of 2x plus 1 will be 1/2 times the derivative of natural log 2x plus 1. That's natural log of u. So this will be u prime over u. Now this right here is u, so we need to fill that in. The derivative of this is 2. That's the numerator. And then the argument itself, 2x plus 1, is the denominator. This one, the derivative of natural log of this argument, again, will be u prime over u, u being the quantity inside, x squared plus 1. So u prime would be 2x over the argument itself. And after reducing these 2's, you should get your final answer. Use the change of base formula to show that the derivative of log base a of x is 1 over x natural log a. So here's our change of base formula, and since the result that we want has a natural log in it, I'm going to use this. So to begin, I'm going to change what we're taking the derivative of to be natural log of x over natural log of a. Deriving a quotient will require the quotient rule. Low d high minus high d low, over low squared we go. So we have a little bit more deriving to do. Derivative of natural log x is 1 over x. And the derivative of natural log of a is the base of the log, just a number. So natural log of a number will give you another number, okay? And when you derive that number, that constant, you're going to get 0. So the derivative of natural log of any number is 0, which results in a complex fraction. We have natural log of a over x when I multiply these two, and then subtract 0, so nothing there, and then all over natural log of a squared. Let's rewrite these fractions so that they are next to each other so that we're multiplying by the reciprocal. Natural log of a over natural log of a squared is just going to leave natural log of a in the denominator. So we get 1 over x natural log a, which is what we started with. If y equals log base 2 of the quantity x squared plus 1, find y prime of 2. So we have this nice little formula here, and u is equal to x squared plus 1, which makes u prime equal to 2x, and a is the base of our log. So a is 2. We're going to plug it in. U prime over u times natural log of a. And that's the derivative. Since they asked us to find y prime at x equals 2, we'll plug in 2. And that will simplify to be 4 over 4 plus 1, so 5 natural log of 2. And we're just going to leave it in terms of natural log.